All right, folks, a very warm welcome to the session about AI agents. This is a two-session event. We'll do this in three parts over two sessions. First part, I'll take you through a general explanation of what AI agents are. It's like an onion. We'll peel it layer by layer. And each layer, as we go deeper into it, it will get more technical. But the goal is that we take people who are not used, for whom AI agents, this is the first introduction to it. And we still take you to a place in these two sessions at which you can create your own AI agents successfully. Right? That's our goal. And we'll do it in three layers or three parts. The outermost layer, we'll talk about what are AI agents, why do they matter, and so forth. A little bit of a big picture, something that we engineers tend not to go into, but I like to indulge in looking at the big picture. Second, we'll take a particular case study, which all of you are familiar with, employees writing their self-reviews. Don't you hate it? Yes. So we will learn to write, we will use an agentic tool that will make it perhaps a little bit more pleasurable to write performance self-reviews. Right? And then we'll talk how to build it up. And then finally, we'll go into the code. We'll walk through the code. It will all be in Python. The framework that we will use will be LangGraph. But these two talks are not about a particular framework. It could have easily been done in Crew AI or in Pydantic AI or with Agno or with Name Your Framework. Right? It is, in other words, the framework part of it is a very thin shim. The sessions are more about AI agent and agentic reasoning, agentic thinking. Does that make sense, guys? So this is how we are going to do it. So remember, we'll start at a very high level. For those of you who are very geeky, do have patience. Sooner or later, we will get to the technical part, right? And it is coming. We'll get there. Now, this, first of all, for those of you who are here for the first time, a very, very warm welcome to SupportVectors AI Training Lab. Here, we do two things. We provide training in all things AI. We have a whole buffet of courses, which I'll probably show you in a little bit, or maybe I could show you right now quickly so I can get that part out of the way. I promise you, I won't keep it too long. So we do offer a few courses. If you like our teaching style and this thing, consider enrolling for one of our courses. 4 courses are about to start next week. These are Foundations of AI, Neural Networks and LLMs. It is theory and lab. If you really want to know how is it that these machines can sing and write poetry and do legal arguments and so on and so forth, you will learn from the Large Language Models Bootcamp about creating AI search, retrieval augmented generation, a bit about agents and multimodal learning and code generation and guardrails and so on and so forth. It's a vast array of topics. But it is the most comprehensive introduction that you can get to generative AI. You come out with a portfolio of real world projects. You do it as teams, and you do something interesting. I'm happy to say that from this place, more than 20 startups have come, literally from the projects they did in the various bootcamps. The next bootcamp is AI agents. You are, in a sense, getting a very simplified introduction or a preface to that bootcamp, if that interests you. Then there's a RAG and AI search bootcamp, which goes into RAG and AI search at a level that, to my knowledge, no one else goes into. We teach you techniques. I mean, our goal is, can you build something equivalent to Perplexity, for example, without the scale of Perplexity, which requires, for example, Cerebrus chips to run on liquid-cooled systems and vast architecture, but something of as much quality, smaller scale, as much quality, and all the techniques that go into creating a really high-performance RAG. RAG is deceptively simple. Everybody thinks they know how to do RAG. Open source projects will tell you 5 lines can do RAG. But actually, RAG is one of the hardest things to do right. To make it really work is hard. And that bootcamp is about that. So those are the 4 bootcamps that we are offering at this particular moment, starting next week. If it interests you guys, you're most welcome to it. And so I'm done with that part of it. I'll just continue now with the main part. So this is me, or some resemblance to me. I'm the CTO here at SupportVectors AI Lab. And my co-founder, Chandra Lakshminarayan, who is also here in the audience. Both of us, we have if you want to know where we are from, we are both from IIT in India. We came here to do our doctoral studies. That's where actually we met, and we stayed friends and collaborators for the last, I believe, more than 33 years now. Right. So, and we are together doing this SupportVectors. We have had a fairly successful industry career. Over our lifetime, we have built industrial systems that have created lots of things. And we have also been academicians along with our industry jobs. I used to teach at UC Berkeley Extension, and then at many places, Urbana, Champaign, and so on and so forth. So this is a bit of a spiel of us, just to prove that we actually know what we are talking about, right? Which is that we have over a dozen production systems with generating revenues of hundreds of millions of dollars. We have over 100 research papers collectively in the SupportVectors team. We mean it. So it's a high-powered group of people. We have over 65 patents, right? So it's a pretty interesting group. But from a training perspective, what is in it for you? We have produced over 3,500 alumni. It turns out they all sleep their way too well. No, I'm kidding. I just put this image there as for humor. So the number of AI engineers and data scientists we have trained so far, we have lost count. It's 3,500 alumni pool. And by the way, this pool is very well connected, and quite often people appreciate the community far more after the courses are over, because they get jobs through the community network. And then we have over 20 plus faculty size. We create an environment that is high engagement. From these chairs that you are sitting on, over 20 plus startups have come. Successful startups have come. Right? Most of those startups actually started their project. They took the projects they were doing in the boot camps and they evolved it into their stuff. So, well, that's enough about this. So now let's come to the main topic that you're here for. And thank you for indulging me with a small spiel about who SupportVectors is. Now we will start with AI agents. See, when we talk of AI agents, the misconception is that agents are something that have happened in the last 2 years. Before that, people did not hear about AI agents at all. It comes as a surprise to people that actually the research community have been doing AI agents for at least 3 decades, 3.5, 4 decades. The term is quite old, but if you look at the definition of the word agent, what does it mean? It turns out that humanity has been trying to create the notion of what today we call AI agents. They have been doing it through the ages. And as I was exploring and learning about AI agents myself, and I began to dig into the core definitions, it took me a lot of historical references. And I thought I would start with a little bit broader perspective so that we don't get fixated on those a few lines of Python code to create this agent or that tool. Let's take a broader perspective, because I feel that helps in understanding what is it all about. And so from that perspective, this is the 4th century BC. There is a king and there is an engineer. The engineer creates an automaton. Right? This is part of the literature in China. Creates an automaton, and the automaton walked, sang, flirted, but then the king was very worried and says, "Well, that's not good." And then the engineer who had gifted the king that automaton said, "Why don't you open the chest and see what is there?" And when the king did that, he realized that it was a mechanical. It was an automata. It was a machine that was singing and dancing and flirting and doing things. So notice the qualities of that machine. It was engaging with an environment, right? The agent, if you think of it today as an agent, its first quality is that it was engaging with the environment, namely the environment in front of the king. It was making autonomous decisions to walk, to sing, to flirt, and so on and so forth, to dance. Right? These were autonomous decisions that the thing was making. And yet it was non-biological. It was a mechanical construction. It was an automaton. Right? And so the king was awed, apparently, and he began to ask the question that will resonate with the discussions that are happening today The question was, can human skills match that of nature? We are in that pursuit, are we not? We are in hot pursuit here in Silicon Valley and around the world, in China and in France and everywhere, to create AGI, artificial generalized intelligence, or super intelligence, or pick your word, whatever is the more fashionable word these days. Are we not trying to do this? Engineer something that matches a biological intelligence. And that is something worth keeping in mind. If you really think, it pervades our mythologies, our stories. For example, the genie of Aladdin's magic lamp story in Arabian Nights. What was the defining quality of the genie? Aladdin could say, build me a palace. What Aladdin wouldn't do, certainly, just to bring out the point, is give it a scripted programming. Do this, if bricks are available of this size, then do this, otherwise do this, go sand like this. You realize that we as programmers, before the dawn of AI, we as programmers are programmers. We write programs. These are deterministic scripts that instruct the machine on what to do. Please contrast that with that of the genie from the magic lamp. When you tell the genie, go build me a castle, the genie says, okay, I have a goal. It goes, autonomously reasons, what does it mean to build a castle? What does it take to build a castle? And does every necessary action, and comes back and says, here's a castle for you. I hope we are seeing the distinction, the fundamental distinction between programming and agents, what today we call autonomous agents. Right? And the crucial word that I'll keep repeating throughout this early part of the talk is autonomous reasoners. Agents are autonomous reasoners that observe an environment, reason about it, think what actions to take to move closer to the goal, and then do take those actions. Then see the consequence of the action, observe it again, reason over it, what happened, and then continue to take the next set of action. And so they stay perpetually in this loop of observe, reason, act. Are we together? This is a crucial point. In a similar way, in the Hebrew mythology, there is a concept of golem. You could create a clay human, write some sacred words, typically on the body or the forehead, and it would come alive, and then it would do whatever you wanted it to do. But as the Hebrew tradition would tell you, the golems can become a nuisance after a while and pretty destructive, right? And so they would need to be destroyed. Some of that resonance you find in the fears of AI. Even today, we are busy trying to create these very intelligent agents, but there is a palpable fear that what if they destroy the world? And you can see the resonance. It has been there for hundreds of years. Actually, and you may think, well, those are ancient references, but no, it goes back even further. And I like this particular reference very much because people don't tend to know this. If you look at the African archetypes of agency, there's something very interesting. In the Yoruba tradition, there is a concept, there's a god, the Urunmila god, deity, and he had emissaries. Those emissaries would infuse themselves in the tribal, amongst humans. Each emissary would have a particular goal, particular set of actions or goals. But collectively, all the goals of the emissaries or actions of the emissary would do something overarchingly beneficial for humanity or for people, right? So it was God's or deity's tangible way of sending his emissaries down to earth to mingle with humans to betterment the situation of humans. And to do that, each emissary would have specific goals and roles. I could not think of a better metaphor for AI agents because inherently the definition of AI agents, much of what we consider multi-agent systems or AI agents is captured in this beautiful narrative that each emissary has their own unique specialized role, a specialized goal and things to do. And what they achieve is the overarching goal through collaborative and cooperative effort, through collective orchestration. So there's a very interesting thing. And there is also a statement that see wisdom is too vast for one alone. Right? If you have ever engaged with a recent large language model, your ChatGPT, your DeepSeek, your Cloud, you would all agree that, at least I confess, that anytime I engage in a conversation with these machines, I am humbled by the fact that I don't know even a billionth of what the machine knows. It is a cultural creation, these large language models. They have captured all of human knowledge, all of human beliefs, aspirations, potentials, emotions. And every time you engage with it, it is almost as though this field of potentiality, this field of human collective heritage personifies itself into almost a person that's engaging with you in a conversation. Isn't that the most wonderful thing? And you can see that I find that very interesting that this African tradition had it, wisdom too vast for one alone, for any human being alone. But that is what these agents or these intelligences are now capable of. And there's a very good quote that I would like to say from the same tradition, Arimila in Yoruba tradition. The god says, wisdom is like a baobab tree. No one individual can embrace it. In other words, wisdom is a collective creation, not an individual prerogative. And the way what are the resonances of that to multi-agent systems? By the way, this picture that you're seeing is a rendering of the Urunmila, the deity. Now, first thing is that, and I find this very interesting, that in some of the most ancient traditions, like agency is communal in African traditions. Right? Emissaries act autonomously under shared goals. Right? These emissaries who come down to Earth, they act autonomously. They're given a role and an individual goal, and they figure it out how to execute on it individually. But there's a shared goal. Right? I find that remarkable that it is out of this culture comes a saying that I like very much, which says that to raise a child, it takes a village. Right? It takes a collective. So you can literally see that a village is like a multi-agent system that must all have a shared goal to raise this child. And then they manage to raise the child well. Right? It is our human heritage. So you also notice that the core ideas of a distributed system, right? Wisdom emerges from parts working together. And there's a modern parallel. See, multi-agent systems in AI rely on the same principle of distributed collaboration. Indeed, the word agents originally arose from the literature, research literature of distributed AI, distributed artificial intelligence, right? And so what are the key takeaways from this little historic digression? It is this: autonomous behavior fascinates across centuries. We have all been wanting something like that in different cultures. The automaton is an early archetype of constructed agency. For example, the Chinese automaton. Right? Technology's roots are deep and human and deeply mythical. It is that our inventions that we do, that we toil away and bring to creation, are deeply imbued with our aspirations. Otherwise, they wouldn't come about. So it's just a point to take away. But then we'll go to the question. So, all right, that's all very nice. Now let's bring it down to the ground. What are AI agents? Now, it is one of those questions that is almost subjective. You ask 5 different experts, and you'll probably get 10 different definitions. Okay? And they will be all fairly divergent. So it reminds me, I'm sorry if I'm using allegorical images here. It reminds me of this picture, which is the blind man and the elephant, right? From the old stories in India. So based on which part of the elephant you touch, you have an entirely different picture of what the elephant looks like. And can't help feeling like that whenever I see a list of definitions for AI agents. So there is a cacophony of divergent definitions. To the API aggregator, like if you are a person who has been writing connectors to this API, that API, there are a lot of companies that do that. Their entire livelihood is that they have a rich box of connectors to all sorts of public APIs, Slack, this, that, Outlook. right? To databases, to and so on and so forth. If you ask them, what are AI agents? They say, okay, AI agent is just workflows, right? Because they live in the world of workflows, isn't it? And to them, it looks natural. It's just workflow. You ask, and you may have heard this, right? So the puzzling question is, are AI agents workflows? And if you ask the programmers, they are suspicious of AI agents altogether, and they will contest and say that they are nothing but microservices and functions fashionably dressed, right? There's some grain of truth to that too. And then if you talk to the research community, and by the way, this is Richard Sutton, one of the fathers of reinforcement learning and agentic reasoning, who, by the way, has been doing this work for decades now and is a Turing Award winner, and the author of course, a landmark textbook, a very good textbook, which will be the real textbook for the course on AI agents if you were to register for the bootcamp. His definition is learning entities in environments. So when you look at all of these definitions, and then even within a more formal people, non-corporate, but more formal research or academic community, there are still divergent perspectives on what makes AI agent. And the reason I'm making it is these things have direct bearing. When we start thinking about a problem and we try to solve it, you'll notice that based on your inclination, each one of you will take a different perspective to solve it. And each of those architectures that you will create will reflect your perspective and will be a valid architecture. So there are many architectures that can be right. There is a lot of flexibility in how you design AI agent systems or agentic systems. And that's the beauty of it. So one perspective is the reactive systems view, which basically says that, see, systems that perceive the environment and act upon it. What it doesn't emphasize is the autonomous reasoning part that much. So according to this definition, chatbots, even recommender systems, or even more, a thermostat is an AI agent. Maybe you may consider that going a bit too far to look at your thermostat and say, marvelous AI agent, right? But you could potentially. So the emphasis is on input-output rather than reasoning, but it's a valid perspective. Another perspective that you can say is that it is embodied intelligence perspective, which is there. So as you can look at this bird made up of machines, it is the form and structure when it engages with an environment. The form and structure enforces a certain kind of collaboration, a certain kind of interaction. And out of that comes agency. Out of that comes the ability or intelligence to solve problems. That's the embodied intelligence perspective about AI agents. And then you have the multi-agent systems framework, by the way, which is a little bit closer to my perspective. It emphasizes, is more on collective rather than the individual, right? So think bee colonies, think ant colonies, right? Think hockey teams, soccer teams, cricket teams. It is the team that wins and the intelligence of the team that matters a little bit more than any one prima donna's activity, right? So that's the perspective of multi-agent systems. Then there is a tool use maximalist perspective. So you may have seen some of the articles that often come out. So for example, one very well-written article and compellingly argued came from Anthropic. Anthropic created a lovely framework called MCP, Model Context Protocol. It is universally, unanimously accepted almost immediately. The adoption of that framework or that was so shockingly universal and immediate. You literally saw that from a word that was just created to everybody talking about it took no time. But the perspective they took is, let's have lots of tools and have one agent who should know, reason, and think how to use these tools to achieve the goal. And they have often emphasized that people over-engineer agentic systems. They create multi-agent systems, unnecessary most of the time. If you have a rich repertoire of tools and you have just one agent, you could do that. Later on, in subsequent work, it turns out recently there's emerging research that may not be so. Problem is, tools can have slightly overlapping functionality, and that today the agents do get confused which one to use. Right, and so, and the other weakness of that is it sort of prevents specialization of it. Like, for example, you want the carpenter to build your furniture, right, and a surgeon to operate on you, but you don't want the same guy to do both. So that's sort of that perspective. So the roots of this, actually, as I said, goes way back, decades, when steam engines were actually a thing still. And I've written on one, and many of you, of course, share that. So the initial work on AI agents was done decades ago in the context of distributed AI. And that's a parting message I wanted to take. This whole theoretical foundation of agents is so strong. It is not a fashion. It's not a fad that has emerged in the last 2 years. Though in the last 2 years, there's been a renaissance in the field, and we'll talk about it. There's no denying it. So with all of these different perspectives, how do we here define it? For the purposes of these two sessions and for the boot camps here, we define it actually in a very specific way, which is close to reinforcement learning perspective and the way academics and researchers like Richard Sutton look at agents. They say that agent exists in the context of an environment with a goal. Are we together? So think of a Roomba in a room, a dirty room. The environment is the room with dirt. Observation is, where is the dirt? It reasons about it. It has tools. What are the tools? It can suck, right? And it has motors. It has locomotion. It can go forward, it can go backward, it can go left, it can go right, let us say, right? Those are the actions available to it, and then the suction. So two tools, motion tool and suction tool. But it needs to look at this room. If you give it a goal and you say, clean this room, learn, and it can learn to clean this room better and better. As you know, if you have ever purchased a room, the first day it looks so scatterbrained, you don't want to be in the room to see how it's working. But gradually it improves upon it, right? So it needs to autonomously reason. And you do that through some goals. What is the goal? Ensure that all the dirt is taken. And the other goal is, of course, the secondary goal is try to do that, for heaven's sake, in the least amount possible. Don't take 24 hours to clean a single room. Does that make sense, guys? So an agent is an entity which is contextualized to an environment and a goal in that environment. It observes that environment, reasons about what actions to take, takes those actions, then the environment, the state of the environment changes. Maybe a small bit. A little part of the room has gone, you just move a little bit forward, a little bit of the space is cleaned, or maybe not cleaned, it was already cleaned, whatever happens. It observes what it did and reasons about it. What do I do next? And then it goes about doing it. So that will be our definition of our AI agent. Autonomous, the key words that I want to emphasize is this cycle. Agents observe the environment, reason about it, and they act upon the environment. Actually, one thing that I missed in this picture is the action part of it. It doesn't reason over the environment, it acts upon the environment. So this image, I just realized is flawed. But okay, autonomous reasoner, observer, and actor. But when it acts, quite often, it has tools to act with. Are we together? For example, the Roomba has built into it a brain, a reasoner. Let's say, I mean, Roombas, I don't know whether they do or not, but let's say a hypothetical Roomba agent. The tools would be maybe the sensors to see the space ahead. It would be actuators. What are the actions? How does it act? It needs actuators. What are those actuators? Motion and suction. Right? Those are the actuators. So now, let's make it a little bit more real. What is between programming and agent? If you want an example, here's a good example to illustrate the point that agent is an autonomous observer, reasoner, and actor in an environment. You ask this question, user asks this question, is it a good time to visit Moi? Right? By the way, I can attest to that. I just came back from there. Right? So the agent observes the user question reasons. It needs weather, flight, and by the way, it's not flight cost, and hotel cost, isn't it? Flight and hotel cost is the typo here. Reasons it needs weather, flight, and hotel costs. Then what does it do? You may reason, but you must have those tools available to empower it. It uses the tools to fetch that information, to do the search, call some external API, do web search, whatever is needed. Then what does it do? That has changed that. Now the environment is in a different state. Before, there was no information about these things. Now there is information about these things. They have come as responses from the tool, output of the tool. So it will observe the responses, then it will reason over the responses, and then it will create a recommendation for you, whether it's a good time to go to Moi or not. Does that make sense, guys? So this is an agent. Please go ahead.
What is good time? Good time, good is relative, right? Good is different for leaders.
That certainly is true. And that also is an evaluative aspect of an agent. For example, if it knows something about you, is the context. If it knows something about you and knows that you would rather not fly, take a $6,000 flight to Moi, right? Or just sleep on the beach without a hotel available, then it will recommend that don't do that.
How food defines good? Like for me, cheap flight is good. Yeah. For him, like the best.
You need to state that. Okay. So that will be in the user. So what it can do is it can ask you, right? Yeah. That what are your what are your affordability parameters, right? Do you what is the temperature sensitivity? For example, is above 85 degrees too hot for you? Right? So good, but that again is what? It is reasoning and acting. Action is revert back to the user for clarification. When you deal with ChatGPT, have you noticed that especially if you go into the pro mode, the very first thing it does is no matter what task you give, it reacts by asking you more questions, clarifying questions. That is agentic behavior, right? It consciously decides that before I go into a long journey, right, let me first get the clarifications. Okay? So that is it. That's the picture that you have about AI agents. So again, we are now gradually coming down. See, the word agent implies built-in. It's something we people don't usually think. But if you look at the word agent, it comes from agency. An agent has agency. When you ask your travel agent to book a flight, to get you a flight ready, you implicitly give the travel agent some autonomous freedom, autonomy to pick some good flights, come up with good decisions. You don't script it. First, visit this site, pick this, click that. You don't say that. You don't program it. Agent implies agency, but there is no agency without the ability to autonomously reason and act. I cannot emphasize this sufficiently. I'll give you a little bit of an autobiographical say. When I started doing AI agents, I knew the academic literature on AI agents for a long, long time, right? Because I've been doing machine learning for decades. Nevertheless, when I started doing it, it's one thing, different thing to actually take it very seriously and start building systems with it. I noticed that some of the first practical systems I built was just, instead of writing C, C++, Java, Python code, I was writing English language. It put some truth behind the word that English is the hottest programming language. I was literally programming in English, not doing agents. It's like the helicopter parent, you know, you're all over the kit, making sure that the racket is properly held in. There is no agency there. The kid doesn't have agency. And so my agents were without agency. It was an oxymoron. It took me a few months, frankly, to step out of it. And I remember thinking that if I ever teach AI agents to somebody, if I ever become good at this topic practically and teach it to somebody, the first thing I'll emphasize and just drill into people is agent implies agency. And there is no agency without the ability to autonomously agentic systems or to micromanage the agents. So why AI agents? It's very good. AI agents can reason, etc. But why AI agents? Right? It's a good question. Why not just use, one of the questions that comes, for example, is why not use a frontier LLM? GPT-5 Pro is there. Just pay the token cost. Forget. Otherwise, you'll have to get developers. They'll do the engineering. They'll build agentic systems. and it will be maybe just as expensive. Just forget about it, use frontier models. Has anybody heard that argument? Right? What's the whole point? So in this context, I'll just actually remind you, because I didn't bring it, there's a lovely paper that came out of NVIDIA recently. We covered it here at SupportVectors a month ago. The title of the paper was, "The Future is Agentic with Small Language Models." I love the title. The future is agentic with small language models. If you want, you can go back and look at the recording. It's a very important paper. What it says is, going forward, most and what used to be enterprise apps, most of you spend your livelihood building either enterprise apps or web apps, right? Web scale apps. Going forward, you'll be creating agentic systems. But when you do that, you will more likely than not be using frontier models. And for reasons that will become clear, you will actually be using small language models, SLMs, because that's a sensible thing to do. Right? So I will capture the gist of it in a sort of a metaphor. Suppose you want to build a hospital which takes care of patients. Would you rather get one super genius who knows all civil engineering, has enormous muscles, and can build it himself, the hospital, knows all electrical engineering, right? And does the wiring, knows all carpentry, and builds all the furniture, the operating theater, and then invites the patient in and says, "Could you please lie down? I need to cut you open." Right? It may be possible to engineer a versatile genius like that, but most of humanity gets by having instead lesser minds like you and me, we the peasants, still have a job. Why? Because we are one-trick ponies and still the system works, a hospital works, right? For example, I might be the janitor there, you might be the electrician, another person may be the surgeon, another may be the nurse. We each have individual roles. So long as we do that one role well, we are good as one-trick ponies. The beautiful thing is a hospital can still efficiently hum along and take care of patients. And you can have such hospitals all over the world, as they do exist. But if you were to rely on one super brain, super genius, versatile, to do it all, there wouldn't be many hospitals in the world. Would you agree with that? And that is the gist of that paper. It said it in much more technical language. But the whole point is, when you try to go and say the way forward is to just scale up the models to bigger and bigger and bigger and have it do everything, what you're saying is you're trying to create that super genius. And the whole point is that goes against the grain of history. Much of biological systems work as teamwork, as individual agents with specialized roles and abilities and skills, but working in an well orchestrated, coordinated, cooperative way. So all of life form is a cooperative gaming. If you think of game theory, unlike chess, which is a zero-sum game, much of life is cooperative gaming. Families survive because they cooperate. The definition of team in organizational theory is a group of people with a shared goal, all working and rooting towards it. Right? So the foundational ideas of agents are all around us. And in some sense, agentic patterns, why build softwares as AI agents, goes foundationally to something we have deep experience with. Right? Agentic reasoning patterns work. There's accumulating evidence that small language models, actually small LLMs is sort of an oxymoron. I should have said SLMs, but the word small LLM has become so common. I use it. So used with agentic reasoning, outperforms by many orders of magnitude the bigger LLMs used directly. There is evidence that not only when you use one-trick ponies, but a collection of them, they can get the work done. They actually get the work done far better than versatile super geniuses. Clear empirical evidence for that.
These super large LLMs span themselves into multiple small LLMs?
At the moment, they don't automatically. They don't. So more aligned to human teamwork and problem solving, which is true. See, we have all solved problems inherently through teamwork. Why not build systems that benefit from all this learning? Agentic reasoning piggybacks on the lessons learned from your sociological team dynamics, right? And we are all experts at it. Since childhood, we learn how to work with others, isn't it? So, and the other thing is there's no going back. Once you get accustomed to solving complex problems with AI agents, there is really no going back, right? It just won't make sense when you see that it works. And there's a rapid growing enterprise adoption, which is, by the way, a good news and a bad news. This year has been the year of Cambrian explosion of AI agents. Everybody and his brother is talking about AI agents. This room is full. It's an evidence that people are interested in AI agents, right? None of you knew whether I was a good speaker or a bad speaker. Nevertheless, you showed up. So it has to be the topic, isn't it? So that is how wide it is. But the unfortunate thing is, and I must say that there is a famous quote by Leo Tolstoy. So Leo Tolstoy, a Russian author, wrote the book Anna Karenina. Most of you have heard of Tolstoy. He wrote the book when he had just gotten married to his sweetheart, whom he loved very much. He was on his honeymoon. A very interesting fellow because he wrote one of the most depressing commentaries on marriage. And the book starts with the sentence, all happy families are alike. Each unhappy family is unhappy in its own unique way. Right? Now, whenever I see people making agentic systems and failing, and I do sit here, a lot of people come to me for advice. Can you explain why this is not working? This is what we have done. Can you review it? Every single time I review their agentic systems, I'm reminded of Tolstoy's quote. Because everybody has made a different mistake, right? And it all comes from, see guys, this is what it is. A generative AI, it looks deceptively easy, but is extraordinarily hard. It's like watching tennis. See, you can see Nadal play tennis. And if all you do is watch him play tennis on your couch, you can give excellent commentary. My goodness, why did he make this mistake? Very stupid of him. He should have done like this. But on the other hand, when we get onto the tennis court, we can barely hold on to the racket. Right? So there is a lot of that happening with AI systems. People think it's deceptively easy. To make the matters worse, there are all these tutorials and Medium articles and YouTube videos that all create Hello World AI agents. The problem with the Hello World AI agents is they're Hello World AI agents. They are the kindergarten of the thing. There's an MIT report that says, most of you have heard of, I don't know if you heard of, X percentage of generative AI projects fail. Does anybody remember what X is?
95%.
95%. Is it a surprise that it happens? Right? Most people underestimate what it takes to create robust, scaled out, reliable agentic system. The single biggest complaint against agentic systems is they are way too expensive, the latency is way too high, and they are unreliable. Programmers have a genuine question. Why would I not do something as a workflow? Why would I do it as an agent question? And I believe they're absolutely right. If something can be done with just a hardwired workflow, it should be done with AI workflow. There must be a genuine need for autonomous reasoning before you do it using agents. But if you do it with agents, there's a 99% chance that whatever you do will fail sooner or later, because most of us underestimate the complexity of creating reliable AI agent systems. Right? There's somebody once mentioned, I don't know how true the story is. Apparently, Bill Gates once said that, or somebody, or was it Andy Grove? Bill Gates said, software prices, right? We create so much more software, but keep the price the same. Right? So effectively, the price is practically free. Why can't civil engineers and mechanical engineers have a similar scaling law? Right? So the response that he got was absolutely wonderful. He says, well, if bridges were made the way softwares are made, nobody would ever cross them, given their poor reliability. Right? It's certainly true about AI agents. I would say that AI agents make traditional software engineering look a marvel of reliability. Right? It's that bad. agentic systems that people crafted. How many of you have heard failure stories in your company with agents? Teams doing agents. I don't know if any one of you would share hands. I can see some hands raised. So that is there. But then again, don't blame the tools for the people who don't know how to use it. Right? That's the core thing. So there are a few agentic patterns I'd like to start with. Again, we are doing foundational ideas, and then we'll boil it down to code eventually as we peel the onion. So please humor me with this. The first part is you use agentic systems to solve complex problems, not to do 2 plus 2. Right? So a complex problem, the best that we know, we as human beings always use a divide and conquer approach. We plan out how to do. You want to go on a vacation, you make a plan, when, how, packing, and everything. Right? You do planning. After the planning, you do task decomposition into separate, well-defined tasks that need to be done. That is important. Those of you, how many of you use Cursor or something like that? Many of you, right? What is the first thing that, by the way, Cursor is in front of you, a standing example of an agentic system, really well done. Right? How many of you use ChatGPT, especially the pro mode of it, thinking mode of it? You all do. When you do that, in both these cases, you'll notice the moment you give it a question, a thing to do, it goes into, first thing it does, it plans out how to go about doing solving your problem. Isn't it, guys? Right? And by the way, these are marvelous and successful illustrations of what AI agents can do. Right? So you do task decomposition. That's the very first thing you do, planning and task decomposition. The next thing is coordination. If you have multiple agents in your system, they need to coordinate, they need to collaborate. It's a given. Collaboration, critique and self-reflection. Why? Like they say, to err is human, to forgive divine. The trouble is, we forgive each other, but we never forgive the machines. Right? If a machine makes a mistake, it instantly becomes an internet meme, and everybody hears about it. Right? So critique and self-reflection has to be part of the agentic system. Well, there's a deeper reason beyond this. The deeper reason is, and those of you who are mathematically inclined would know it, generative models are harder to create than discriminative models. To generate something, to create something, is a lot harder. But for the same entity to then go back and critique it and say, is it right or not, actually is easier. So for the same brain, which may struggle to create something, it is far easier for it to reflect back on it and realize that it's flawed. Therefore, critique and self-reflection has to be baked into agentic system, because as of circa 2025, the large language models on which these agents are based are certainly not error-proof. Right? But you can mitigate those errors significantly through critique and self-reflection. That's important. You need memory. If you're doing something, you know how much of the work you have done, what state you are in. Otherwise, you're in trouble. Just like with human beings. When dementia sets in, you have no memory. So you go back and ask the same question over and over again. Right? And like it happens to me. You can tell from my age, I lose my keys every day. Even though I might have, every day I decide, I'll keep it at this place. And of course, I won't keep it. Next day, I have no recollection where I left my keys. Right? So memory is very important. You don't want your agents to look like me. Right? So you need tools. Obviously, tools empower the agent. The agent may come to the conclusion that I need to find out how the weather is in Maui, but how will it do that? Unless it has the tools to, it is the actuation part, the action part of it. It needs the actuator, the tool. So the tools are both sensors, and here I use the tools in the actuator sense, but then and I separated it out from the sensor. But sensor is also a tool. A camera is a tool. Right? Reading your code is a tool. It's a sensor tool. Right? So when Cursor reads your code, what is it doing? It is observing the environment, isn't it? When it is fixing the bug in your code, it is doing what? It is acting upon that environment by changing the code. But between the observation and the changing the code, there has to be the necessary step of reasoning over the code. And that, you would agree, before these AI agents came out, couldn't be done using deterministic code. You couldn't program, right? You couldn't write a program that would be a universal debugger of all other programs. Would you agree with that, guys? And that's the fundamental distinction between AI agentic reasoning and programming, if you want a clear illustration. Right? Well, so we are in the renaissance of AI agents. What makes AI agents powerful today? Of course, it started with large language models. Remember, the crucial element, observation is through tools, actuation also through tools. For decades, the one thing we didn't have is an autonomous reasoner. Two things happened. The moment large language models came in, people noticed that you could use them as autonomous reasoners. Right? They showed ability. This happened as soon as November 2022, ChatGPT came out. Everybody woke up and said, oh, voila, the missing piece has fallen in place now, and we can create agents. And you would see one of the most influential papers that we'll talk about in this thing literally came out shortly after. An amazing paper, in one of the most quoted paper in many disciplines, not just AI, in many disciplines came out of that. Then the next big breakthrough that came is in February 2025 of this year, when we, in the open source at least, successfully created true reasoning language models. Actually, embarrassingly, since LLMs came out, they could not reason. They seemed to reason simple thoughts. You could coax it with chain of thought prompting, but you couldn't actually truly make them reason. True reasoning, at least in the open source world, came with the DeepSeek R1. And then OpenAI also had, but a closed source version called Strawberry, which they later on released as, I believe, the GPT-5 is now, the reasoning model. But reasoning ability is very, very recent, to the extent that agents, the true reasoning LLMs came since Feb 2025. That's just 6 months ago, isn't it? 6-7 months ago. You literally see that AI agents is on fire, because now there is nothing holding it back. You see that, right? Now, you cannot say that this reasoning ability is absolutely perfect. It needs evolution. There are even researchers who question whether it is true long-range reasoning, but there is clear reasoning ability. It can get better, it will evolve, but at least the missing piece has fallen in place, and now we can do a true AI reasoning. And that is the renaissance we are facing. So where does its empowerment come from? It comes from tools, of course. And in this case, remember I talked about Anthropic and their model context protocol for tools. What they said is, it's just like a laptop. If all the two, your printer, your scanner, your camera, your everything, you connect them through the USB-C. So long as they have the USB compatibility, it doesn't matter. You can connect a gazillion devices, isn't it? And the laptop, which would be a proxy for your AI agent, you can talk to all of them, isn't it? So MCP, literally, people liken it to a USB connector. It's a universal format. It made minimal promises. It says, okay, we just want to be a minimal standard for tools, a USB connector. And then everybody fell in line, and it became a rage. So it has gone to the extent that it has gone outside the agent community. It has gone outside even the AI and machine learning community. It turns out that people with traditional APIs are converting all their APIs into MCP tools. In fact, those of you, if you have a little bit of familiarity, I'll just jump the gun. If you use Fast API, in one line, you can convert any amount of microservices into MCP tools, and therefore make it available to the agent. So just think about it. Like, we have been so immersed in a world of microservices and REST APIs, isn't it, guys? All of that, with a couple of lines of code, becomes available to you free as MCP tool. Think how totally empowering that is for when it comes to creating enterprise AI agentic applications. Is it a surprise that the CEO of Salesforce was the first one of the first SaaS companies, right? Software as a service companies, enterprise software as a service companies. Early on, seeing all of this made a prophetic statement that most people agree with. He says, enterprise software is dead. What could he possibly mean by that? Means programming of enterprise software is dead. Because most of enterprise softwares, what do? They are workflows, complex workflows that use certain APIs and get things done. But if all the APIs can be made into MCP tools, then you can, instead of hardwiring logic, reasoning in code for, if, while, this, why not leave an AI agent, a reasoner, to dynamically reason all sorts of scenarios? Because then what happens? See, what happens is no matter whatever application you build in the enterprise, it will only address a minority of the use cases. You only address those use cases which are most commonly used. Those of you who do business intelligence know that. You create the so-called standard reports in the dash. But then the bane of business intelligence is every customer wants the custom reports. Right? Why? Because there are too many, the combinatorial possibilities are near infinite of what a particular situation may require. Right? And for each of them, you need a different SQL query, different kind of report, and so forth. So you know that. And so enterprise software is like that. What a user may need is very fluid and dynamic, which is why once you build a product in software engineering, what happens is you don't just build a product, you also build job security for the engineering team that build the product, isn't it? Because so long as that product sells, it will keep changing. Requirements will keep changing. Customers will keep asking for more and more and more. And so here you will have all these engineers happily buying houses around Silicon Valley. Right? It's a fact of life. But then comes the converse part of it. If agents could reason about it and dynamically create those workflows, then what happens? You realize that you went from a software whose size scaled with the number of engineers you had in the stable, right? To you can scale as much as you want without increasing the number of engineers. Right? It becomes invariant to the size of engineering. And that is the great promise of AI agents. And that is why there's a general belief that as this technology matures, software, enterprise software, not all software. See, at the end of it, if you think of a tool like grep, nobody claims that you can replace grep with an AI agent. It's a near perfect tool. It has been the workhorse on any Linux system for years. Right? Tools and the software behind the tools will always be there. Software engineering, doing core functionality, I believe will always be there. Now, code generators may make it easier to create those tools. Nevertheless, those core pieces of software will always be there. But the part where it is true, the part where it won't be true, is creating these workflows, of which there are near infinite variety, and each workflow seems to fulfill the need of a niche group of clients. Isn't it? That is best addressed with the AI agent because it removes what is fundamentally a showstopper to the scaling of enterprise applications, isn't it? And so it removes that blockage, and now you can scale up enterprise. And we are entering that age. That is why, well, of course, Salesforce is coming out with Agent Force, right? Is their framework. We won't go. In our thing, we'll not talk about any proprietary framework, but nevertheless, a point. Where else does the power of agents come from? This is the most common thing. If you look at a tutorial on AI agents, it will start with prompt agents. So most people feel that AI agents is nothing but a prompt wrapped around a LLM call. How many of you believe that? You do, right? So many of you believe that. Because that's how it is in most tutorials. Actually, no, that's not true. All that prompts do is they clarify the role and goal. Are we together? They clarify the role and goal of the agent. Now, you do good. That thing requires prompt engineering, which you all are familiar with. We have all these books on how to write good prompts. But then there is also technologies which are very effective actually in agentic frameworks like DSPY, which are called prompt optimization techniques. DSPY, text, prompt, many things. But DSPY is the most popular amongst them. And even with close to 30,000 stars, I believe it is still an underappreciated GitHub project. It's very, very, it's a gem. You give it the best prompt that you have, and then you can ask it to further improve it. It will dynamically figure out even better variants of it, right? For a given LLM. Where else does the power come from? It comes from orchestration. Because there's a famous statement by Casey, who used to be a Yankees coach. He said, see, Yankees is a very marvelous team, right? He said that, see, to hire superstars is easy. Right? It takes money, convincing. You can persuade them to go join your team. To make them actually work together well as a team is the hard part. Many of you who are in management know that it's easy to hire bright people, and then you are in deep trouble. Right? Because to make them work together is hard. So orchestration, collaboration, and coordination is actually a crucial part. Now you can do it by multiple means. You can do it through frameworks, some frameworks like LangGraph, QA. That's where the agentic frameworks come in. Right? All of this, LangGraph, QAI, Pydantic AI, Agno, so on and so forth. They come in, they make it easy. But as you will learn, frameworks are part of the narrative. They are necessary but not sufficient. To really do orchestration and coordination well, you need a very difficult form of reinforcement learning called MAR, multi-agent reinforcement learning. Like you give it an objective of how, you reward it on how well the team collaborates. The agents collaborate with each other in achieving a goal. And that's a very hot topic of research and being adopted now. Specialization. The renaissance of AI agents, but the final thing is, see, power comes from specialization. Just like in a hospital, the efficacy of a hospital comes from the fact that the surgeon does surgery, the electrician does the electricals, the civil engineer does the building, and the janitor does the cleaning. Makes sense, right? Specialization. How do you achieve specialization? You can take a general purpose LLM, but generally you will notice that there are two approaches people take. They will take a giant LLM, frontier LLM. Oh my goodness, GPT-5 is released, we must use it. Right? The trouble is, it's exactly the same problem. You incur a massive token cost, right? Because it's expensive. And by the way, agents really show you what a big bill you can incur. Right? You get really fat bills when you do agentic systems. Or the alternative is you take small models. It's like one individual, one human being who has gone through a specialized training, like a person has gone through medical training to become a surgeon. You can take one ordinary, bright enough human being and make a good surgeon out of that person. That is the philosophy of specialization. That is the founding philosophy of civilization. Cultures, civilizations are formed through specialization of labor, right? Division of labor and specialization. We all become good at different things. How do we do that in agentic systems? Through fine-tuning, supervised fine-tuning, and through reinforcement learning. Now, to the extent that we want agents to be autonomous reasoners, they have some reasoning ability, even as a LLM coming out of the box, because they have been through some reinforcement learning. But to do your domain-specific, task-specific specialization, highly recommended. There's emerging evidence that you must also finish it off with RL, with reinforcement learning. It really takes the agent to a new level of specialization and efficacy. See, guys, those of you who are actually coding agents, and we'll get into the technical part, if all you do is prompts, it's English. Small changing of the wording can cause the LLM to misunderstand its goals, the agents to misunderstand. It's brittle. It's likely to fail unexpectedly, right? Because think about it mathematically, what is happening? Those prompts become vectors. They go in. In context learning is taking place just in the forward signal transduction, right? The LLM is learning and trying to do your job. It's an in context learning. And on a very small compute budget, it has to do both and produce a result. Would you trust that? Or would you trust a machine that has gone through hours and hours and days of lots of data, examples, back and forth, reward? This is right, that is not, this is better, do it this way. That is reinforcement learning, right? Common sense says that you want to bake it into the personality of the agent to do the right thing, right? That is the value of reinforcement learning. In contrast, if you just do it through prompts, it is like, you hire an engineer and you just give the engineer a mission critical task and say, here are the instructions, go do it. Very likely that the engineer may make mistakes, Right? It's sort of an analogy to what happens. So I highly recommend take RL seriously. Then that is to make agents very good, specialized. But what about collaboration? We just talked about it. Easy to hire great guys, but hard to make them work as a team. So then you need another kind of power. What you do is you create a shared reward. You reward when they all as a team do well, right? So I'll give you, and you will see an example of this, right? So how do you achieve that? So you can do it through good flow design. So for example, if you use LangGraph, you can say this will give it to this, will give it to that. What is deterministic, what you can decide upfront, you can do as a graph, right? But there are many things that may not be deterministic, that has to be dynamically determined. And so you need to optimize. There are methods of doing reinforcement learning. The topic is called MARD, multi-agent reinforcement learning, a very hot topic. Yes, and I'll show you a very funny video in a break. We'll come to a break in a moment, and we'll do that. So MARD, and what are the challenges of MARD? First problem is the non-stationarity. Do you see this picture of Roombas? The room is still dirty, and they are all hitting against each other. Right? So why is that? Because see, what happens is, suppose in a dirty room, you have one Roomba, right? You give it a go, clean this room in the least amount of time possible. It acts upon the environment, it changes the environment, then it reasons, and it decides the next set of action. The environment is still the same while it is reasoning, isn't it? It's not changing under its feet. But when you have multiple Roombas in the room, what happens now? It cleaned a little bit, it had some idea of the environment, it starts reasoning about it. And then by the time it goes to do something, the environment has changed. That problem is called non-stationarity. Environment is fluid in real time, right? And that makes these kinds of problems rather hard. There are other complexities with the loss function definition and gradient flow and so on and so forth. I won't go into those technical aspects, but that makes multi-agent reinforcement learning a little bit of a harder problem. And people are making great strides in recent months on that. The other thing that is happening these days, and just giving you a frontier of where we are going to, the frontier, there's a concept of ambient agents. These agents they quietly, you don't need to prompt them to do something. They'll be passively, quietly reacting to environment signals. They're forever observing in the background, right? And they'll be reacting to environment signals with careful reasoning and appropriate action. So you see this picture of a dog, very much like the dog I had, actually. She would be sleeping next to me. The moment I would wake up, I wouldn't even move. Somehow she sensed I am up, right? I barely even opened my eyes, but she would know I'm up. And she knows that it is morning, early dawn, and she's all over me. Let's go for a walk. Right? Let's go for a hike, because I go for morning hikes. It was a daily thing. And I often think that that's a perfect example of an ambient agent, quietly just there, watching the relevant signals and reacting to it, taking actions, reasoning over it, and knowing, it's morning and he's awake. Let's go. Right? So that is an ambient. Other more practical example is keep observing your health. For example, look at your watch data, right? Smartwatch data, and your stride, your other things. And if it sees anomalies, it reaches out for help in case of physical duress. For example, it might call your loved one, it may call your physician, whatever it is, right? Call 911 and so forth. That's an example of an ambient agent. Ambient agents are a big thing going forward. Then the other big thing that has happened, which is amazing, is, and this is the great potential, and everybody is talking about it. It is when you put reasoning LLMs together with robotics, you get this lovely new thing. The very powerful thing, the merging of two streams, it is the physical AI agents, right? Which can actually do a lot of, especially in industrial setting, this is a really, really huge deal. Right? A little bit about multi-agent systems. The power of multi-agents, so team rules. We all know teamwork rules. We all work in teams, right, as engineers. What makes highly effective teams get things done? We all know. Definition of a team is a group of entities rooting for a common goal. Notice that I use the word entities, not human beings or not biological entities, right? But entities. It could be agents. True for biological systems as well as for AI agents, and inherently a cooperative game within the agent. Like in game theoretic perspective, inherently a cooperative game, right? There's a shared goal. One of the most beautiful things you observe in agentic systems, multi-agent systems and teams is behavior that you didn't expect to happen. There's a remarkable research paper I'll touch upon immediately where this becomes apparent. It's one of the most amazing things that was discovered early on. So just like flock of birds, if you're going down Interstate 5, you must have seen this over the farmland. Each of these birds is an autonomous agent. Nevertheless, you can see these beautiful patterns. When a predator strikes, for example, a flock of birds, each bird will make autonomous decision on how to escape the predator. If you work out what would have been the globally optimal solution to avoid the predator as a flock, the beautiful thing is what they did collectively is exactly the same. And that is emergent behavior. And one of the most amazing things you see in agentic systems is emergent behavior like this. So again, I won't harp upon this topic. Good agentic systems have a specialization. Each player has a very focused and well-articulated role. There has to be a raison d'etre. You don't just go on adding agents to your system because you can. Each player brings some unique or differentiating contribution that's absolutely essential to achieving the goals effectively. This is captured actually by a person who got a Nobel Prize for it, Shapley. Shapley, by the way, he did many influential work, and he was a colleague of the scientist around whom the book was written, The Beautiful Mind, or the movie Beautiful Mind was made.
John Nash.
Exactly, John Nash, and his theories for cooperative and non-cooperative games and the equilibrium, Nash equilibrium. So his Shapley and he worked together. Shapley's contribution was this: suppose a team works together and achieves a goal. Right? Let's say that a team comes together and together they found a successful startup. The startup makes $1 million revenue or net profit. How should the net be shared amongst the team? Now, there are many ways of doing it, right? Perhaps one way, maybe give everybody equal share. You might say, well, that may encourage the slackers. In India, by the way, that happened. The Indian government tried for many years, tried a socialistic model. And what happened is they noticed that a lot of the government employees hardly ever worked because the pay is the same for everybody. The other alternative is the more plutocratic way, which is that the founder keeps all the $1 million and then gives a pat to every team member and says, "Great job," right? And because you did such a great job, I'm not going to lay you off, right? Be grateful. That's the second way. And then there is a scientific way, a mathematical way. The mathematical way was discovered by Shapley. He wrote an equation which is absolutely brilliant. It says, how should that $1 million be divided? It's based on Shapley value. It gives you a fair, based on your contribution, you get that, right? And so the basic point I'm making is, in cooperative games, it's essential to know the Shapley value. If you create an agent, know what is its Shapley value from a game theoretic perspective. Is it really essential, right? Otherwise, remove it. Flawless collaboration. See, in a surgery room, the surgeon may just stretch the hand and the assistant knows exactly what tool to give at this point in the surgery into the hand. That is flawless collaboration. It's essential. Now, I'll talk about a paper that's very interesting, and just for a minute, and then we'll have a break. See, generative, and then we'll continue. Like I said, I didn't tell you when the session will end. So, generative AI. This paper, I said it has close to 1,000 citations. I was wrong, actually. It has close to 3,000 citations. A paper that just came out in spring of 2023. I don't know why I wrote 2012. That's ridiculous. 2023, early 2023. Right? Remember, that was the time when ChatGPT had just come out. This remarkable paper came out from Stanford. What they did is they created a multi-agent system. So remember, agents require an environment. So they simulated a village, a small village. The village had a library. The village had a school, had a coffee shop, had a mayor, it had a chemist. There were these agents: mayor, chemist. Chemist was the husband of another professor. The professor had a son who was going to college, right? Different things. Normal life they simulated. They created these agents. And what did they do? They gave them a role and a goal. Goal was just to live their life, normal life, expected life. That is simple. They didn't give any other goal. They said, go live your life. This is who you are. And then something most remarkable happened. As they interacted with each other in a most remarkable emergent phenomena, they saw sociological dynamics spontaneously emerge. I'll give you two examples. One person talks to another and says, oh, I heard that, let's say, I forget the personality's name. Let's say Harry is trying to be a mayor, standing up for a mayor. The other says, I don't like Harry. Somehow I don't have a good feeling about Harry, and so on and so forth. So then this person goes around. After a little while, he talks to somebody else, and then his opinion changes. And then he says, I think I'm going to vote for Harry. Right? So now in human society, there is something which you call diffusion of information. Mysterious term, right? But more practically, we call it gossiping. Right? So civilization rests upon gossip. Right? There's even a theory that says that the reason we have this big head compared to others, compared to the size of our body, is because it is the biggest head that can still pass through the birth channel, right? And that has the capacity to gossip. Right? Most of it is used to gossiping, apparently. I don't subscribe to it, but I'm telling you a legitimate scientific theory. So gossip is foundational to the propagation of information in human societies. What they noticed is exactly the same behavior in this paper. They found that information is being propagated through that. They observed, for example, that the idea emerged that Valentine's Day is coming. And guess what these agents spawned without any prompting, without any programming, without anything. What they started to do is they started to propose to each other, will you be my date to the Valentine's Day party? They organized a party, Valentine's Day party, and they all showed up at the party with their dates. See, these are things that can never be achieved through programming. Do you realize that, guys? These are emergent social dynamics, and it is acting from autonomous reasoners, living out their lives, their roles, isn't it? This paper was groundbreaking early on, and it garnered interest from many fields, as you can imagine, from anthropology, sociology, psychology, to many things. People have repeated this study. This was done by, I believe, 23 agents or 14 agents, but now they have done it with millions of agents and all sorts of complex dynamics, very practical use. Suppose a wireless company wants to decide where to plant a tower. The density is spatially uneven of people in a town or city, isn't it? Not only is the density of humans spatially variable, they're dense in some locations, not in another location, but through the diurnal cycle, it keeps changing, right? People go to work, suddenly the suburb gets empty, workplace gets crowded. You see that. There is a sports event and everybody is in the stadium. Things like that. There's a sale at the nearest supermarket, and before you know it, there's a stampede there, or there's a 4th of July, or there's a Thanksgiving sale, and everybody is there, right? So there's a very complex human dynamics. Everybody is individually making decisions. Nevertheless, the population shifts, density shifts. If you want to decide where exactly to optimally plant the tower, what would you like to know? You would like to observe that dynamic and see when exactly do you reach congestion and where. Does that make sense, guys? And therefore, you can use it for such practical applications. Right? So that is that. Now, in this paper, and I won't go much into it, you can see these things: clarity, clear articulation, personality, very strong personality, memory stream. So what the agents would do is that they would live their day, remember the things, but then do abstractive summarization. See, if I were to ask you, what did you do today? You can give me a log of every activity since you're waking up. But if I were to ask you, what did you do last week? You will not be able to recount. What did your mind do? It has an abstractive summarization of what you did last week, rather than, a blow by blow account of everything you did last week, isn't it? So that is how you manage good memory streams. They showed capacity to reflect and critique. For example, a person changes, why am I not liking this mayor? Maybe it's a good mayor and I need to vote for him. And the rules of engagement with other agents are clear. For example, how should a chemist agent engage with a customer? It's a well-defined rules of engagement. Right? So that's the thing. It was marvelous paper, and I won't go into it. Where are the agents used? So the cliche is the moment you start looking for tutorials on AI agent, the first one that comes up is travel agents. Right? How many of you have seen those tutorials? Right? Some of you have. Actually, AI agents make absolutely terrible travel agents. Right? You end up paying too much. Right? All this, a flight, the sites would love it. The airlines would love it, and hotels would love it if you use AI agents. Right? Don't. That's a anti-pattern. Don't use AI agents for travel. Yeah. So
is there a reason for that?
Because they will just surf the web and look up the prices. The prices on the web, published prices, are never what you should pay. I'll give you an example. If I have to go to India and I try to book a business class ticket, today it would be something like 8,000, 9,000. The published price. If I go through travel agent, my travel agent, she gets me the ticket for 3,500.
Please sponsor.
Sure. So, yes, please go ahead.
Yeah, depends on being model or like prompt engineering.
That's right.
Depends on you how you're training, and these are tools and APIs you're in.
No, that is absolutely right. Now, I was making fun of the typical tutorials that are on the internet because all they do is just use Google search. If you Google search your ticket, as you must have learned from experience, when you buy the ticket by Google searching and going to Travelocity or one of these places, you pay double the price. You pay published prices. You need a human travel agent to get good prices. So you need to train the agent that call this person. Yes, that's right. So what are the legitimate use cases? See, think of customer support. Right? Typically what happens is, let's say that your laptop is old and it needs repair, and you are on the line and helping. That is also a great opportunity because the customer may say, I'm getting tired of this laptop, I want to upgrade. That should immediately prompt a collaboration with the sales team, isn't it? Right? And so on and so forth. So what happens is, a typical interaction with the user should truly be a collaboration between the tech support, the customer support who can generate confidence, the coordinator, tech support, the sales agent, and all of them together. Today, what happens? They just bounce your call back and forth. It's inefficient. But a good multi-agent system will do what? You can put one human being who is being guided and prompted by a multi-agent system, AI agent system in the background, that is listening to the conversation and giving suggestions on how to navigate that conversation best with the customer. Wouldn't that be lovely? And that is, by the way, one of the big use cases, right? And I believe Salesforce is pursuing that heavily because, see, how many of you have a call center background? Typically, the average handling time of a call center call is about 6-7 minutes, isn't it? Or 10 minutes based on the product you are dealing with. What happens is, typical customer call center agent is paid $15 to $20 an hour. The company that is providing you the call center agent gets a bare $25 an hour. Margins are tiny, literally tiny margins. I studied the data. Our research group was the first to study the largest data set, big data, of customer call centers around the world. We did that 12 years ago, and with interesting findings. But the thing is, margins are very tiny. Now, if one agent can handle 10 calls, let us say, per hour, and is being paid, let us say, let me just say $15 an hour, right? So per call to the company, it costs $1.50, isn't it? $1.50. So is it any surprise that I heard, I don't know how true it is, Salesforce announced that if they have a customer service application, which you can use as a subscription for the low price of $2 a call. $2 a successful engagement, right? So you can see how the economics of that works. But why will they be able to succeed with that? Because they believe that AI agents can do the job better, right? They have more information that they can bring to bear in the given situation. It's happening now. It's really happening now as we speak. Collaboration. So suppose you want to write an article based on latest news. You need research, you need many things. So for example, marketing literature, research papers, business plans, creative writing, often anything collaborative. Agentic systems are great. Right? In fact, one of the first projects we do in our AI agents courses, we literally ask you to design a complete newsroom on a topic. So there will be researchers that will search the web for the latest happenings on that topic. There will be copy editors, which will then decide which are valuable, right? And evaluators. And then there will be copy editors who will create a draft. There will be legal experts to make sure you're not getting into legal trouble for saying whatever it is that you are saying. And then there would be the presenters, the people who create the whole layout of the paper, the visual layout of the web page, of how should the information be presented. And you do it as a multi-agent system. It's very effective, actually. This is literally the first project you do in the AI Agents Bootcamp, if you were to do it with us. Right? Virtual teaching assistants, I kid you not. What people did, I think in the first batch of AI Agents Bootcamp I gave, they didn't tell me. They were actually in that room, they were doing it. They were all very confidential about it. Then in the end, they came out with it. What had they created? They had created a virtual asset. It mimicked my voice. And you could ask it any question. And what it would do is, of my 700 videos, which are online, it had scraped all the knowledge, ragged upon all the knowledge. It would create an answer, and it would speak in my voice. Right? And it actually fooled people. Other people thought it was me answering the question 24/7. Right? That is the potential. That really happened. And it was not my prompting. Those participants were themselves autonomous agents, so the goal. Right? They did achieve that. And by the way, that application is there. I can invite them to demo it. Healthcare. Classic case. You have a heart problem. Let's say that you have grown fat. You go to a cardiologist, you say, oh, you have too much pressure on your heart. Don't exercise too much. Don't hike. Right? You go to the diabetologist, he says, goodness, given your weight, you better exercise and lose weight. Right? Otherwise, you're not going to survive. Right? Then you go to a physical fitness guy and he says, absolutely nothing but lifting weights from morning to evening will do. Right? You go to the orthopedic and he says, are you kidding? You already have osteoporosis. Right? So who do you listen to? Right? See, there's a very interesting history. Medical world is filled with contradictory advice. Right? And so one of the great things that Cleveland Clinic and Mayo Clinic did, and the reason, you see that in America, healthcare is practically broke. Right? We spend the highest amount every year on healthcare, and we get one of the poorest quality of service in the whole developed world. Right? In the midst of this absolute collapse, catastrophe, and disaster, there's still clinics like the Mayo Clinic are shining examples of stellar healthcare, and people around the world fly into Mayo Clinic because they had a simple idea. What they said is, every patient must be looked at by a committee. The committee will be of different specialists who will bring their different perspectives. Then the whole committee will meet in a meeting and collectively decide a course of action. So in medical world, you speak of SOAP, subjective objective assessment plan. They said assessment must be collective. And then collectively you come out with a plan of what to do. Do you see, guys, that's a prime case of agentic systems. Those were human agentic, multi-agent systems coming up with the diagnosis. The fact that it works, the proof of that is the fact that Mayo Clinic and ECQ, as Cleveland Clinic, etc., are the stellar gems of healthcare in a country that has practically a catastrophe of our healthcare because other hospitals are not following them. Each one of you go to a doctor, get a different advice. You really hope to God that that advice is right, isn't it? Because if you meet another doctor, you'll get the opposite advice. So what do you really need? You can use agentic systems, each agent representing a different specialization. Good news is, especially this year, already medical agentic systems, AI systems, are almost at par and above par than fully trained physicians. So it's an excellent use case for bringing many specialists together. Now, what do you get? See, Mayo Clinic, why isn't there a Mayo Clinic down your street in Fremont? Because it's horrendously expensive to create a system like that. It doesn't scale, isn't it? You cannot get that high quality talent to come together, form a committee around one patient, and then come up with a decision, isn't it? So you are seen by a primary care physician, right, who knows a little about everything, but not much. But then look at agentic systems. If agentic systems inherently are scalable, see, one of the things that we live in an era of zero compute cost. See, you and I are peasants, right? So when we say zero compute cost, what do you mean? I look up the price of RTX 14 of 5090, and it is going at exorbitant price of $3,000-4,000, even though the MSRP is 2,000, which itself is exaggerated. You want a Blackwell, 40,000, and you can't get it. You have to wait in line. But actually, if you look from the point of view of the hyperscalers, for them, money doesn't matter, right? Because the applications they build out of it, they bring so much revenue. The benefit to cost ratio is so very high by orders of magnitude that the denominator, that the cost of hardware, compute cost is quite literally can be approximated as zero. So in a world of near zero compute cost and therefore a completely falling cost of intelligence, right, where intelligence is becoming orders of magnitude cheaper by literally every quarter, in such a world, do you realize that you can create a truly scalable Mayo Clinic kind of model, healthcare system, using agents, AI agents. And that is the great potential of AI agents. You see that, right? So I can go into more applications. Supply chain, you can imagine that so many people coordinate and decide what to buy, how much to buy, how long to hold it in inventory, and so forth. Big impact. Urban planning, so many departments, sanitation department, electricity department, water department. There was a real case, for example, in India, I forget the city, in which typhoid happened. There was no reason to it. It was not the rainy season. Why would typhoid suddenly spread? They found out is because in their infinite wisdom, the water pipeline was put under the sewage line. Sewage line leaked, and presumably the water pipeline also leaked. There was typhoid. How can that be? Why was it happen? Because these two departments weren't talking to each other. It is actually a forgivable error. Urban planning is one of the most complicated things you can do. It is very, very, very error prone. There is no urban planning you can do without making mistakes. Such gross mistakes, egregious mistakes, of course, should be avoided, but small mistakes abound. Isn't this a typical use case for agentic systems? Isn't it? Because agents will not get tired, will not sleep. They can go on thinking about every single permutation and everything that can go wrong and every scenario possible. They'll work through the combinatorial explosion and tame it down and figure everything out and come up with an urban design that actually will work, isn't it? That's the potential of AI agents. Robotics and industrial automation is literally happening. We talk about digital twins. What you can do is you can have the physical world and the virtual world. In the virtual world, for the robot, you create a twin. You create a factory floor, you create a digital twin of the factory floor. What you do is you put autonomous reasoners here, agents here. As things happen there, it's happening here. When it happens here, these agents can reason and do things. What you can do is you can see whether that action is a good action. Right? So there's a safeguard there. If you notice it's a good action, you can just say, okay, and then it will get replicated by the physical robot on the actual physical shop floor. The potential of that is just unbelievable. See, at this moment, US is not much of a manufacturing country, so you don't hear this part of the news very well. But if you go to the Asian countries, go to South Korea, you go to China, and so on and so forth, they actually have dark factories where there is no human beings, and therefore there is no reason to even keep the lights on. It's all pure robotics now. So the old mental picture that we have, the 20th century, that factories are people where thousands of people go to work, is long gone. Today, most modern factories have no workers at all. In fact, today, modern ports have no workers at all. It's fully automated, and AI, physical AI is taking over this way. And it is not something that will happen. It is something that has happened, and it is fast taking over the world. It's one of the great success stories of AI agents. Right? Unfortunately, it has military applications. Right? As you probably know, recently there was a Indo-Pak bit of a fight, right? The interesting thing is it happened. It was perhaps the first big fight that happened in the era of AI and AI agents. Believe it or not, there were swarms of AI agents in the sky helping coordinate the moves, right? To attack. The old system used to be that there would be radars on the ground, there'll be airplane observers, and then there'll be fighter jets which knew what to do, which would be seen, and whatever they could see, they would shoot at the target. Now the whole doctrine of warfare has changed. Now what do you have? The pilot who's actually going to fire a missile does not even know what to do. He just takes off. He's told to take off. There are satellites in the sky. There are radars on the ground. There are airplanes with AWAC systems from long distance observing. Collectively, they're coordinating, and using AI, they are making decisions. It's a multi-agent system. And the decisions they are conveying to the pilot who's actually going to fire a missile. So the entire doctrine of warfare has changed. Right? This is real implication of agentic systems. And the scary thing, in one of the very important reports that an ex-OpenAI person said, that report is called Situational Awareness. I encourage you to read it. It said that the most optimistic situation will be that the world will be caught in a heated AI race. The worst prognosis is the world will be destroyed in an AI war. It's happening. So there are many open source agentic frameworks. One of the ones, believe it or not, the earliest one is AutoGPT. It is a single agent system, right? And single LLM agents, very easy to do, drag and drop. It has over 166,000 stars. The most popular open source project. But for serious work, don't use it, please. It's meant to just learn and play with it. Right? Then the one that is most widely adopted is LangGraph these days. It's the most adopted, and it has proved itself for orchestration in industrial scale, right? Large scale. It works. So we use it quite a bit. Now, all this Uber and all these people use it. It turns out that some of the biggest houses like OpenAI and people like that, they actually build their own agentic system. They don't use an open source framework. They have the in-house systems. Creo AI is another very popular one. I love the title actually, Creo AI. Creo means team, right? And it speaks to the multi-agent nature very, very well. Then AutoGen is an older one from Microsoft, and there are many. PhiData has gotten renamed to Agno, again, a very good one. Llama agents, Burr, and one notable absence, conspicuous absence is Pydantic AI. I should have added it in the slide deck. So guys, I'm done with the presentation part. Remember, we'll do 3 parts. Presentation, followed by, we'll take a case study, we'll take a real thing and think how to solve it. So we will collaboratively think. Let us act as agents and together work out a solution to that case study. And then next time when we see you on Wednesday, we'll walk through the solution code. Does that make sense, guys? Because then we'll get fully technical. If you don't want to get that technical, then you can skip the Python part of it and the design patterns and system engineering part of it. But we'll start peeling the onion one by one. But before I do that, may I show you a video? It's an old video actually, and a lovely video that merits seeing. So 2-minute papers, hide and seek. If you Google this word, yeah, go ahead, please.
I had a question regarding your story with the travel agent and how you get better pricing with a live human agent versus uh, any AI agents and that sort of thing. In that scenario, what is the latest thinking on how effective you want AI to be? Because the discourse for I think in a lot of society is to what extent will jobs be replaced and how good do you want these AI to be? Is it actually a preferred scenario where a human travel agent that actually can get your best prices is actually preferred, and that our goals when we make AI actually is maybe just get to a baseline level? Because all these things that can be done computationally, they can be done at scale. So you're essentially getting rid of, wide classes of occupations.
Yes, you addressed a very, very good question. What does it do to humanity and our pursuit of? See, you and I are peasants. We work for daily wages or monthly wages. We are well-dressed peasants, go to air-conditioned offices, but we are peasants, right? Working for, and so we have jobs. What happens to us? Actually, no one knows the answer. I'm reminded of the book Charles Dickens, a classic author, wrote a book, Tale of Two Cities. It starts with the famous line, "It was the best of times, it was the worst of times." And it ends somewhat paraphrasing with the sentence that, in short, it was so much like the present time that the authorities insisted on describing it in superlative terms only. So if you look at the news, there will be a set of experts, very serious, deep experts, who are very apocalyptic about it. There are also a set of experts who are extremely optimistic about it. I actually happen to do AI in HR domain, so I'm very cognizant of what it is doing to the labor market. So let me give you some peek under the covers. Is it going to lead to massive job displacement? I guarantee it. It's happening. Guys, there's a bloodbath in the Silicon Valley. You all know it. Some friend of yours has lost a job. It is happening, no doubt about it. Is there what does it mean? Will it lead to massive concentration of wealth into the hands of the few who can afford to harness the AI systems to their advantage? I guarantee it will happen. Will it usher in the next dark ages? Because that was the definition of dark ages. The feudal lords had everything, the peasants starved and shivered in cold. Right? Will that come about? We don't know. Because the converse of this is, see, as we are worried about this, look at the younger generation. They are so excited about AI. They're creating so many new things, new forms of art, new forms of business, new forms of things, that the counter argument is that technology is always transformational. It always leads to loss of one kind of job in the creation of another kind. Horse and carriage has gone away, but motor car taxi drivers came about. If the latter theory is correct, and they are claiming, in software, for example, they are saying that because of the acceleration, because you can write code faster, right? What it will lead to is far more software possible and far more business opportunities and far more success. Who knows? But it's certainly societal guard. I personally believe societal guardrails are needed. For example, a universal basic income is an absolute necessity just to safeguard that people don't starve. See, we as engineers, we may go down as history as the creators of the biggest wealth generator in history, or we may go down as the villain who ushered in the next dark age. It's absolutely anywhere in between, and it's anybody's guess. No matter how much data you study, whosoever I talk to, serious people will tell you it's anybody's guess. Nobody can tell. Jeffrey Hinton was asked, can you predict in NPR, can you predict what will happen next year? He says, I can't predict what will happen. No, what 5 years from now? He says, no, I can't. Can you predict what will happen next year? He says, I can barely tell what will happen next month. Right? And the world is changing, is in complete flux. Globally, it is in flux. In every area of science, it is in flux. You can call it the best of times. Medicine, for example, thanks to AlphaFold and the proteinomics discovery of protein structures, people say that more cures and more drugs are being discovered now than ever before. They are saying that medical science, I have it from a big authority, who I'm proud to say learned actually his medical, his AI from this room, but he's as a leading edge healthcare authority. He tells me that more medical science has been created in the last 6 months than in the entire history of medicine. Look at that. So we don't know. We don't know which narrative to follow, which lens to frame it with. And nobody knows. I don't know if that partly answers your question.
Yeah. All these things happening in academia or in the secret market?
Everywhere. Today, I mean, one of the big democratization that happened with deep sea carbon release, everybody realized that they can all train their models. Right? If you go to Africa, for example, the whole continent of Africa is exuberant about AI. They are the most optimistic continent about AI. They feel that this one technology is the final wealth generator that will lift Africa out of poverty. They genuinely believe that. Right? And their DeepSeek adoption is very high. Indian government has adopted DeepSeek, right, models, and they want it to be used in all our colleges, etc. The new Indian government, for example, decided to create massive investment in semiconductors as well as AI because they know that this is the future. China is at this moment quite literally the AI leader. It's doing extraordinarily well. Rest of the world is in hot pursuit. For better or for worse, everybody knows that AI is now an existential issue. It is not a thing to be left to the specialists. The whole human race is predicated on the development and responsible development of AI. We can steer humanity into dark ages, or we can steer it into the next golden age. So you and I sitting here would be written down in history as the usherers of the golden age or the greatest villains. We don't know. Go ahead.
What is the difference between the orchestration with the land graph nodes, decision-making nodes, and the workflow with the specifying task which has associated LLM task? Because both the cases we do the orchestration and we have the decision-making. In the orchestration part, we are making the decision-making in the land graph nodes. But in the workflow, the same thing we are going to do that.
I will give you an example. See, workflow is a static. Invariant of what happens, you move forward or you have hardwired rules. Suppose something like this, the robot has to go and fetch you coffee. But after it steps out, the environment is fluid, it is raining. The robot has to improvise, the agent has to improvise and decide, what do I do? Right? And if you really look at the number of things that could be happening in the environment, the car may be broken, the other thing may be happening, something may have blocked the traffic. You cannot write a workflow or do it at all, completely as a workflow. Combinatorial explosion takes place. And so you have to make it fluid and reason in the moment. And that makes it into AI agent. See, a self-driven car cannot, you cannot create a car through programming. The number of possibilities in corner cases are infinite. But what can you train? You can train a loss function with simple goals. Try to kill as few people as possible and not kill the passengers, right? And still go from place A to place B, right? So yeah.
In the defense and military slide, that reminds me something. Can we replace the fighter jet pilots with agentic AIs? And
that's definitely going to happen. Human beings' reflex times is so bad. Today, many of you who own Teslas would testify that quite often it takes a protection maneuver in which you were phased out and it knew that you're going to have an attack and it took over and protected you. Right? Human response times is terrible. Today, no spaceship is launched with human pilots or astronauts in control. We know that that would be dangerous because when you're taking off, those critical moments, human reflex times is too slow. You need to really be very fast to take over. More than that, coming down, you're landing on Mars. It's a very complicated maneuver. How do you land a nuclear-powered, basically a Humvee, through complicated maneuvers and parachutes, coming down at such a high speed into the Mars atmosphere that the whole cone is burning. You cannot see anything. You're just seeing a cone of fire coming at you. Under that, you have to do a complicated maneuver, slow down, coming at tens of thousands of miles an hour, you need to slow down in this little time, right? And launch a parachute and figure out that in this landscape, what is the optimal place to land, which is a flat land, not to land on rocks, right? And land successfully. That's not the time for human reflexes. So almost all complicated and mission critical things are already done by AI. Get over it.
So next World War will be like two agentic AIs fighting.
As I said, situational awareness report says that the worst case scenario is it will be the war of the AI agents. Anyway, guys, please humor me with this. I know it's getting a bit later. I want to show you this, and then we'll discuss the case study. You guys can think over it, and when we meet next, we will unpack and solve it. Does that make sense?
Yeah.
Right? Okay, guys, so just watch this video. It's fun, and then let's take a break.
OpenAI built a hide-and-seek game for their AI agents to play.
So, guys, I hope you got some introductory flavor. I would like to end the first part with this video. Let's take a 10 minutes break. And those of you who are interested in the technical deep dive, so many people told me they want a general introduction. So I've made it like an onion. So general introduction is over. Now I would like to go down and take a case study. And let us discuss how would we solve it and build agentic system by hand, like by drawing, do a system design. And then next time we'll go into the code. All right, guys, welcome back. So after all of these things, we should start doing something. But before we do it, I'd like to tell you guys a joke. Are you guys having fun?
Yep.
Okay. So there's a story. One man dies and he has done equal amounts of good and bad deeds. So that goes up there and the angel Gabriel is waiting and says, I have no idea whether to send you to heaven or hell. So let's do this. We'll make it your choice. So go check out heaven. He goes there and he says, oh yeah, people are singing hymns in praise of God. They all look very serious and nice people. Very nice people, but a bit bored. Then he says, okay, let me check out hell. He goes to hell. Oh, there's an aroma of excellent coffee, which you all must have felt. There is great food, great conversations, very interesting people. So he says, he goes back and he tells the angel, I think I'll go to hell. Right? I've thought about it and I'll go to hell. And the moment he goes back to hell, the devil is waiting with a stick to beat him up. And even the coffee is old. Right? And I do tell this joke occasionally to tell you that, well, he asked the devil, so what happened? It all looked so nice a little while ago. And the devil says, well, then you were a guest. And now you are a member. Right? So in the same way, maybe at this moment you guys are guests, so it's all easy. But when you actually do register for the course, it will be a little more technical and a little more purposeful. I wouldn't say it would be hell, but let me just say that I hope it's not hell. It will be fun, but you'll come out really well baked. You'll have mastered this topic really well. So, all right, the problem that we'll solve is another hell. Most of you work for corporations. I'm sure you delight writing self-reviews at the end of a performance cycle, let's say annual or half yearly or whatever. How many of you absolutely love it? Nobody. How many of you feel, I wish this didn't exist? Okay. So, well, it's a bane of life. It's a necessary evil. Organizations do it. I, by the way, happen to be in AI for HR. I happen to know that most of those reviews are totally ineffective. But it's a ritual we all have to go through for legal and compliance reasons. So here's the thing. Imagine, let us look at the stakeholders. You are the user, employee. Employee, there's a manager, and there is a HR agent, making sure that everything is fair and above board, right? And the context is you have to write a performance self-review. Performance self-review for a certain period. This is a periodic. Let's say yearly, for example. Typical performance self-reviews are orchestrated like that. You are given some technical goals to achieve, some projects to finish. You are given some mentorship work, teamwork, collaboration, etc. to do, and something else, some social responsibilities. What did you do to help this cause or that cause? And these are typical staple diet of self-reviews. You all must be familiar with it. So what we will do is we will create a agentic application that will help both the employee to write good reviews or know when the review is good enough to submit, and for the manager, because those of you who have been in leadership role all know the most tedious thing is to read self-reviews. How many of you feel like that? Right? And the more you move up the hierarchy, by the time I became SVP, I used to get submissions from people under me, directors and VPs, that would be a mile long. They have achieved so much, right? And no achievement left unmentioned, right? So it used to be pretty long, right? And it's rather tedious to study that. So what you want to do is, let's look from the employee perspective. What you want is the employee needs some feedback on how good the review is, metrics. And did you focus on outcomes or just work? Because companies care for what was the result of your work rather than how much the details of your work. Did it actually move the needle? Did it lead to more revenue, bottom line, whatever it is? Outcomes matter, clarity of your review, things like that, metrics like that. That is what matters. So we will, for employee, we will create a metrics. Let's call it a radar board. So along different axes, it will tell A, B, C, D, E. Let's say F, 6 metrics. One may be clarity of language, one may be completeness of review, self-review, another may be achieve outcomes rather than details. Right? How much have you achieved? And some employee may be like high here, this there, right? There's something like this. Will every employee's review should come out as a metric, as a feedback on how your self-review writing is going, right? Then, and this is the use case we will do. And then for the manager, what we will do is you would just produce a very tight summary of the most relevant information, right? One, summary. Secondly, wouldn't you like that key highlights, key achievements are extracted from the long write-up? Right? By the way, when people write, especially when people are immigrants like us, for example, English is not my native language, I make lots of typos and lots of grammatical errors. It's common, right? So one of the things you would like is just rationalize text. Whether we know it or not, actually, language which is infused with grammatical errors and typos is an irritant, is a subconscious irritant. Right? So you would like to have that removed. So that you don't want to form a negative opinion about an employee who has done brilliant work simply because the language in which it was written was infused with typos or grammatical errors. So you want to read the rationalized text rather than the original text. Does that make sense, guys? You would like to extract key achievements and rank them most important first. In other words, a descending order of quality of achievement. Would you like that? Does that make sense, guys? Right? It would be worth having this. And the employee would like to have a feedback. What should I do? I do in case the metrics say you wrote a poor self-review. Should I do to improve? Because having done brilliant work, you don't want to be sort of not being given fair reward simply because you didn't write the review well. So this is a useful case. Should we make it an agentic app?
Yeah.
Right? So we will make it an agentic app. So what are the things we can do? Let's think of, given a text, review text, if you want to summarize it, how would you summarize text? See, remember, a machine that can summarize, a tool that can summarize text, or something that can summarize text, needs to understand language. It has to be a language understanding machine. Those are called language models. Therefore, you'll use an LLM. Now the question is, should that LLM be an agent or should it be a tool that the agents can use? Which one makes sense? And why a tool? Because summarization is a horizontal task that it's a common task that many agents in different contexts may need, right? So if you deploy it as a tool on a server, different agentic systems, the HR agentic system, some other legal departments agentic systems, others, they can all be reaching to this tool to just get the summarizations. Does that make sense? Therefore, it is a prime candidate to be made a tool rather than an agent. Because if you make it an agent, it will get baked into your particular agentic application. This is more appropriately a tool.
So isn't there a model that's doing the tool calling itself?
No, so the implementation of the tool will inherently internally use a model. But it is also true that if whichever agent calls this tool is itself a model. Do you see the interesting thing, guys? And the reason I took this example is because many people are in the misconception that tools are not models. For example, if you have a tool that changes text into capital, right? Something like that, just capitalizes the string. Everybody would agree, yes, that is a fair tool. Why in the world would you want to do that? I don't know, but it's a fair tool. But the moment you say, oh, summarized text, people begin to say, no. It is it's an agent. Why? Because it's using a language model. You do hear that. But I'm trying to say is that no, there's no such distinction. Architecturally, a tool is a reusable component. Right? Those of you who are used to the language of reusable components, the mindset that you should have is it a reusable component whose use transcends this particular application? If the answer to that is yes, it is a tool. If that functionality, its use transcends this particular application, then it's a tool. Are we together? Think library, something like that. Likewise, rationalize text. Just make basic grammatical fixes to the text. So we agree that this we can make into a tool. What about rationalized text? Some text is there, might have minor typos, non-clarity, minor contradictions. You don't want to change the text, you just want to fix minor typos and grammatical errors, etc. Is that a tool or is that an agent?
It's a tool.
It's a tool. Now think, extract key achievements. Is that specific to self-reviews or is it something that the legal department will need or finance department will need to do their revenue projection? Specific to that. So you would want to make it into an agent. Makes sense, right? Or at least, and see what happens is that even when you make it an agent, what I tend to do as a best practice is I always have a suspicion that tomorrow I might need to make it a tool. Because just when you made it an agent, the other department comes and says, can I please use your functionality? And then you realize, I wish I'd made it a tool. So what I do is I keep the code away from these specific orchestration frameworks like LangGraph, CrewAI. Don't hardwire it. Write your code separately, the core of it, right? Of your key extraction achievement, extract key achievements. And write an agent as a shim around it. Because if you change your mind, you can easily make it a tool. Does that make sense, guys? So it leaves you the flexibility of bouncing back and forth between tool agent decisions. But for now, we'll make it into an agent. This is what we'll go with. And then the metrics. This should be an agent because this agent is.
Can I ask a quick question just so that this confuses me all the time? A tool can in itself be an agent as well, right?
Absolutely. Or another way to say it is that if an agent can be a tool to another agent. In other words, another agent may look at you as a tool. So guys, we all think we are autonomous reasoners. We walk into the building and we think, oh my goodness, we are really, look at our shirt and so forth, professionals. What does the company look at us as? Tools. And therein is the reality.
Nowadays, all these data platforms, they have started giving agents by default. For example, we know that you have data.
Yes.
Data extraction.
Yes.
You need summarization. you need, some things to for the data to flow is very common.
Right.
Try and provide agents by default with particular object.
Yes, it's an emerging
Then
trend.
you have your business.
That's right. That's right. So yeah, excellent. So we'll make these two agents here, and we'll make two tools. Simple application, guys. Have you reasoned through it? Now, would you like to see a little demonstration of it today? And think on how you would implement it. And for now, we'll just take LangGraph as a framework. But as I said, this is not a course, this session. So today session is not about LangGraph. We have to use some orchestration framework. We'll use it minimally, but we'll focus on agentic reasoning or agentic patterns of thinking in the solution. Go ahead.
Just a simple question. Do you need to have an MCP in between the agents and the tools?
Absolutely, excellent. This is MCP. We'll do all the tools through MCP. Excellent question. By the way, there was one question that somebody asked, very good question somebody asked, and I said, can you please repeat it for everyone so I can answer? Could you please do that? Please turn on the microphone and ask this question. One of you can please give a microphone that behind you. You get close to it and ask, please.
This question is overwhelming me, sir. So I would definitely like the perspective on that. If AI agents are trained on human data and our society at a global level has its own biases of various kinds, so at least at the inspection of that model, AI model, there we are feeding our own biases and our own concepts and opinions about society. And like we saw that open AI game, it does look like it is kind of following some of our social parameters, which we see in our society. So would there not, would people who think of it differently or are outcasts for the society, will that also apply for AI agents, and how does that?
Thank you. No, thank you. This is a very insightful question, and great that you thought of it. See, guys, AI, these large language models, AI, they are cultural and civilizational constructs. They mirror human cultural values as of this moment. So the great peril is that they will perpetuate those values, those biases, not only the good, but the bad, the biases. If racism is there, when people build language models, they have to take a lot of effort to mitigate known biases, racism, sexism, ageism. Effort is made to wipe those out of the model because they are trained on web data. Web is filled with toxic content. It's a fact of life. So the great peril with language models have been that to the extent that they are mirrors of civilization, they come with all the problems. To give you an illustration, and see, there are biases that we have that our grandchildren will be ashamed of. They will say, "Can't believe grandpa or grandma used to think like this." Right? How shameful! It is bound to happen, right? Because we don't know where we are wrong. I'll illustrate this with a historical fact. Aristotle, the great Greek philosopher, was sure that men are better than women. A self-evident fact. Why? Oh, because men, for one thing, have bigger heads and they have more teeth. But then somebody could have pointed out that elephants have even bigger heads. And if he had bothered to open Mrs. Aristotle's mouth, you may have noticed that she has the same number of teeth as he has. Right? Nevertheless, it was a cultural, civilizational bias that men are superior to women. Only recently in human civilization, it has gotten, I wouldn't say eradicated, but let's say mitigated. But every culture is unaware of its biases, especially the harmful biases. Subsequent generations discover it. So to the extent that these AI agents are cultural mirrors of civilization, the risk is they perpetuate, even accentuate those cultural values, some of which are toxic. It's a fact. Go ahead.
In these AI agents or non-AI agents, we use different LLMs. So if we change one from instead of OpenAI, if we are going for Google Gemini or Claude, so will there be a change in the response or thing whatever?
Oh, it's a wonderful question. Thank you for asking that. What happens if you? Yes, the answer to that is yes. So because your prompts, the agents are highly sensitive to the prompts you write, to the models you use, And one of the things that you will learn in this course through prompt optimization, systematic, is how to not have that happen and how to custom train your own models through reinforcement learning so that you have very, very robust and predictable behavior. See, what you want is the intelligence of AI, but the reliability of hard-written, hardwired code. You can actually achieve both. You can have the cake and eat it too. But unfortunately for that, you have to register for the course. All right. All right, guys. So Chanda is now going to show us a little bit of what the solution may look like. And you guys think, how would you build a solution using LangGraph? And next time, we'll do code walkthrough when we meet on Wednesday. Chanda?
Yeah, I will share my screen. So I had this, I already ran it once. So this is the dashboard. So Asif, you want to talk through it?
Yeah, let me talk through it. So this is what we were talking about. Imagine a solution like this. It's a minimal, guys. We have kept the code base as simple as possible because it's your foot in the door to the world of AI agents, right? So if you frown upon the UI as too simplistic, it is deliberate, right? Besides the fact that it gives us a lame excuse to hide our incompetence over AI design. Like, we are AI experts, not UI experts. So, so here's a text. So imagine a lazy employee who is writing a self-review and says, I had an eventful cycle this summer. I learned agentic workflows and implemented a self-review agent for the periodic employee self-review process. It significantly improves employee productivity for the organization. So guys, when you look at this as a manager, what are the deficiencies you see? APIs are missing, isn't it? It's not quantitative. Outcomes are not emphasized. Many things are missing. Plus, it has spelling mistakes, etc. So, first thing we want to do is not have a person read this, but read the rationalized text, with the grammatical mistakes and these things removed. Which is this? So, this is it. A rationalized. What it does is it does not change your language, just fixes the grammar and typos. More readable. Then the next thing we do is summarize, because when managers face a mile-long self-review, which I've had the misfortune of facing, right? You hunger for a summary that does not lose the signal. See, important thing is, and so guys, when you think of how to write this agent, see, anybody can write a summary. I once heard a joke. A person learned speed reading. It used to be a thing in my generation. Speed reading books. So somebody said, okay, did you read War and Peace? He says, yeah, in 20 minutes. Wow. What was it about? It was about a war, Napoleonic War. Missed the entire context. It was the whole deep philosophy about the human condition in the face of adversity is missed. Right? So the thing is, when you summarize, you cannot lose the signal. Right? So this is it. How do you write a summary? Think, how can an agent, AI agent, summarize a text in a lossless way, as lossless way as possible, keeping all the signals. So this is it. This is a summary of that. Let's go to the word cloud, which gives you a qualitative feel of what is it about. Something, employee, cyclic, employees, eventful, summer, self, etc. Right? Let's go up a little bit. And then let's go to the achievement. What do you want? You want an AI agent to just itemize the key achievements of this employee as an HR manager or as a manager, isn't it? So it turns out this employee has only one achievement, right? Implemented self-review agent, improving productivity. Right? So one good reason why you should take the full course, you would have more achievements, right? So, all right. So, impact is on the team area and details this summer. Let's look at the review scorecard for the. Oh, as you can see, the outer dotted line is the baseline that your score should be above this threshold for it to be a good review. You notice that this review misses that score on every axis possible, isn't it? And so if you look on the right-hand side, let's look at the left sidebar. When you run this, it shows you a progress bar. So as the agents go about doing the work, agentic applications are heavy lifters. They take a long time. Latency is huge. Multi-step complex task decomposition. Remember, we talked about it. So as each of the tasks gets done, it would be nice to give UI feedback that it's gotten done. So we are having there were issues found with the self-review text. Please study and fix these. One of them, there are too few achievements. Right? Solution, elaborate on the details and add more measurable achievements, KPIs, right? Then try again. Does this look a somewhat useful agentic application, guys?
Should I go ahead and update it? It will.
Yeah. And so, yeah, let's update it with a longer one.
Yeah.
Let's see what happens when we put a more properly written self-review.
I will start it. It will take some time, but you can, in the meantime.
Okay, guys, so here is a person who has taken some pains to write the self-review, but as you can see, the person is still, so this is this half I mostly, the language is
I will go to the view mode. It will be easier to read it.
So you can see the language is colloquial. It does have typos. It needs some level of rationalization, etc., isn't it? It would be nice to have it without typos, but it is thoughtful. Do you see that the KPI is present here? Quantitative numbers. It's a qualitatively different beast compared to the previous review. Let us see how our application does with respect to this review. Right? And unfortunately, this is where actually agentic systems shine, the vein of it. It's a pretty complex thought. What we are saying is, and I'll give you a hint of what's going under the covers. When you ask it to rationalize, that's okay, it's fast. But when you ask it to extract key highlights, you realize that you need to reason over it. You need to be able to not only understand the language, but reason what is the signal that cannot be lost, isn't it? And how important that signal is, how important that achievement is, and stack rank those achievements. Does that make sense? In other words, the employee should agree that this is a good stack ranking of the achievements, and the manager should be able to trust this tool that this agents did a good job, right? So let us see if that works out. It will take some time because reasoning tasks take a lot of time. We are using at this particular moment. Did I tell you that don't use frontier models, mostly use small language models and reinforce RL train them. But because this is an introductory course and those things you'll learn in the main course, what we have done is I've gone against my own advice. I've just used GPT-5 for the simple reason that we won't get the bandwidth to do RL and all this deep stuff. Right? So we have used this. Now, GPT-5 is very interesting. Once I asked it a question, and it took more than 24 hours to answer. Right? It did an amazing job, actually. I would imagine that the output that it produced, the report that it produced, if I had given it to consultants, it would have cost me tens of thousands of dollars. But it does a really good job. But the other side is it thinks. So sometimes you feel that if you just say hello, it will think.
Yeah, like ChatGPT-5 is deep thinking mode, right?
Yeah.
So every time you ask something, instead of thinking.
Yeah. Actually, try it in the pro mode, and then you'll realize it really does a very good job. So it is thinking, and while it is thinking, guys, I'll give you an idea. Extracting key highlights is a reasoning task, or is it a non-reasoning task? So let's think through our cycle: observe, reason, act. What is the environment? The user's text. Right? Observation is of the text. I mean, the environment is the whole application, but the agent needs to only focus on the text, the signal. Then it needs to reason over it. And then it needs to act. What is the action? Highlights, ranking of the highlights, isn't it? It needs to come up with the ranking of the highlights. A word cloud is simple. Do you need a reasoning model to create a word cloud out of a text? It's a brute force text. It's not even AI, isn't it? Then Chandra is running, right?
Yeah, it is running. So it is happening in the back. That's what I'm showing here.
Then creating performance metrics, evaluating the text for not for what the guy achieved, but how well he wrote or she wrote her review. That is a metrics that is meant for the employee to get some feedback. How is she doing in writing her review? Is that a reasoning task or a non-reasoning task? It's again a reasoning task, isn't it? And when let's do one thing, guys. against, I was going to not show you the prompts, but I'll just give you a quick glance at the prompt. One of the mistakes that people do is they write too short a prompt. When you have a task like this,
should I open the prompt?
A key achievement system prompts is good. Yes, let's take it. And let's maximize this. Yeah. So you notice that this is a pretty long prompt, very carefully thought out. There are many good prompt writing templates. Everybody has their favorite. The one that I prefer is actually one of the oldest prompt templates. It is called the CoStar. The reason I like it is the Singapore government does everything in a very methodical way, right? Buildings, every decision is methodical. So when the LLMs came out, they said there has to be a proper way of writing prompts. So they created a government committee to sit down and create the right way to prompt an LLM to get optimal results. And then they created the CoStar template. And the proof that it works was that one young girl, she used the CoStar template and actually won a prompting competition, national prompting competition. So it does work, and we have seen that it works. What it contains is context. Give the context. What is it? The role, the context. Give the objective, right? So that is the CO. Style. In what style are you making it, right? Is it formal, informal, this and that? And see, measurable, like who is the audience? Tone, is it professional tone, neutral tone, etc., in which it should respond? Audience, who are you saying? Sometimes, you don't understand it. Don't you say, can you explain it as though you're explaining it to a kindergartner, right? On the other hand, if you're really expert at the topic, you'll say, assume I have a PhD in this, right? So the audience matters, because the LLM modulates its response to that. And it goes back to something that is important. It's called the theory of the mind. In psychology, it's called the theory of the mind. It is that when you and I communicate, the reason we communicate efficiently is because I have an implicit theory of your mind. I know you guys are a technical audience. So I don't have to explain every technical term. When I use the word LLM, it means something. I assume you understand, isn't it? That's a theory of the mind. So communication is more efficient. In fewer words, we can communicate. But if you don't have a theory of the mind, then what happens is, imagine you're a customer support agent at a very busy computer repair shop, and a customer comes in and says, what is happening to my computer? I haven't heard in 3 days. The agent is totally lost. What will the agent do? Oh, could you please tell me your name? We apologize, and so forth. First thing the agent will do is create context. Isn't it? Go back and look at the history. What did this guy give for repair? What was the mistake that the user did? Assume context.
Yeah.
That the other person knows who I am. And so I go to the shop and start barking at the fellow. So with LLMs, unfortunately, when people interact, they don't realize that LLMs don't know you. Actually, there is increasing research evidence that the first thing the LLM does by reading your text is it creates a theory of your mind. It tries to create a picture of who you really are, what your age, what your thing is. And then it responds, right? So, all right, let's go back and look at, so anyway, let's finish the prompt first for a moment.
Okay.
So that is the audience. Just tell what it is. All of these things are helping the LLM better understand you before it responds. And then output, you can tell in which form you give the output. Then it's always a good example to give some good thing, to give a few examples and other things. So I will let you write the prompts. I'm going to release this project on GitHub after the next session, but hopefully before that, see, in the beginning, right, it's a tall order to expect you to learn RL and MCP and all of those things. But surely you all know prompting. So for this situation, think, what are the prompts you'll create for each of the agents? We can do that, right? So think through the prompts. That's an exercise or homework I'm giving you. Think through your own prompts and see, try it out and see how well it works. So let's go and look at the results now. So now when we look at it, you notice that the sentences start without capitalization and there are minor grammatical errors and typos, spelling errors. So let's look at the rationalized text. Do you notice that those things have gotten fixed? Yes, they seem fixed. It's a little bit more readable. It just takes the friction out of reading a text. Now let's go and read the summary. And if you're a manager, I hope you'll attest to the fact that I wish this was right there up front for you, isn't it? Right? The summary is there. Do you notice that in the summary, all the signal is preserved? The KPIs are preserved. See, don't summarize like that guy who says War and Peace is about the Napoleonic Wars. So you have to create a summary that preserves the signal and does justice to the employee's achievements. Let's look at the word cloud. So it was a data engineer. So you can imagine that all the words are about Airflow, platform, and some finance application, marketing app, etc. This is it. Now let's go look at the achievements. And what do you notice? The achievements are accelerated checkout pipeline and freshness. And it categorizes the achievement by impact areas, performance, reliability, quality, revenue. By the way, anybody feels it's mildly useful at least? Yeah. Good. It does that and extracts this from it. And then let's look at the as a feedback to the user. And by the way, it is in order of most important achievement first. See, this is what agents shine at. Right? This is the labor saving. Imagine having somebody to have to, a manager to have to sit and extract it from an employee's review and then forward it to HR and give those as grounds for promotion. Because the very next thing every employee does right after writing their self-review is either ask for a hike or a promotion. Yes. Or both. Right? Or both. So that's that. Okay. And what are the lessons you learn in senior management is every time you see a director come towards you, run, because the first thing he'll say is, my projects, everybody is so overworked, I need 5 more people. I need 5 more openings. So anyway, we'll move forward. Let's go to the metrics, review scorecard. So what do you see? You notice that it more or less exceeds every of the requirements, except conciseness. Would you agree that all things looked good, but maybe it lacked a little bit in clarity and conciseness because the language was colloquial and it was a bit lengthy, right? But it was specific. It had KPIs. It talked about ownership and leadership. Like the person mentored, did good things. Collaboration was mentioned. Outcome over activity. It said, we did achieve this rather than I did this, I did that, I did that. Right? So, well, this is the app. Think how would you build it? Simple app, right? But I hope this illustrates, I needed to create something that would be simple enough for people to get started. At the same time, would have at least minimal utility value. Right? So guys, we are going to put it on GitHub, public GitHub. It is there on GitHub, but public, make it public. But before we do that, would it be nice if you tried something on your own? Yeah. Right? So try it, guys, and I'll see you on Wednesday. And those of you who have questions, please feel free to stay back, and I'll end with that. And then I'll be open to questions till the last of you have left.